Good day everyone, I am Michael, moderator for this webinar. I welcome everyone for today's webinar, which is HVAC and GMP environmental control for pharmaceutical clean rooms. It's a pleasure of mine to introduce our presenter for today, Roger Cowan. Roger Cowan is the founder and owner of R. Cowan Consulting Services LLC, a consulting company specializing primarily in pharmaceutical contract manufacturing. He has 35 years of experience in pharmaceutical quality assurance and manufacturing. I would now like to hand over the floor to the speaker. Over to you, Roger.
Well, thank you very much. And as was said, today is the webinar on HVAC, and I'll be presenting this to you today. So I'm starting off with a definition of a clean room. Now, there's two terms in the industry that get thrown around. That's environmental monitoring and environmental control. They are two different things. So what are some of the regulations around HVAC? Another GMP reference, CFR 211.46 states. So those are a couple of regulatory references. Now, over in Europe, EMEA Annex 1, they had their own set of specifications and classifications for clean rooms. Now, EMEA also has specifications for microbial contamination. Now, if we look a little closer at ISO 14644, the original classification standard, Federal Standard 209E, that's the one I referred to in terms of the class 100, 1000, and so on. That actually was canceled November 2001, and it was replaced with this documentation, ISO 14644-1 and -2, by the way. Okay, so let's jump into HVAC, and let's look at the main component of HVAC systems, and that's the air handling unit. So diving a little deeper here, an AHU consists of fans, coils, and filters within an insulated metal box. Now, the cooling coils in that AHU, it typically circulates chilled water or propylene glycol. Now, this is instead of the direct expansion refrigerant that's normally used in industrial units. Also, pharmaceutical air handling units should be located on a separate equipment space. In other words, a floor above the clean rooms to allow access or maintenance without disturbing the clean room areas when you do that. Okay, so moving from the AHUs to the clean room itself, here's some design considerations. Now, construction of the clean rooms. Internal particulate generation comes from three sources: the ceiling, walls, and floor surfaces, people, and equipment. Also, during the construction, have a minimum of wall-mounted protectant ledges, shelves, and cupboards. Okay, so now we're going to move on to airflow patterns within the clean room. There's typically two airflow patterns, non-unidirectional and unidirectional. Now, on the other hand, the other airflow pattern is unidirectional. This is characterized by a single pass airflow in one direction. Now, when you're talking about unidirectional airflow, there's two types. Again, there's vertical and horizontal. Vertical airflow comes from the ceiling, HEPA filters, and it goes in a laminar fashion to the floor out through the return ducts. Horizontal airflow streams from the wall, one wall to another wall in a laminar fashion. So anytime you're talking about clean room suites, you have to look at differential pressure, or delta P. Now you have to have differential pressure between cleaner areas and areas of a higher particulate classification. How about airflow rates? Airflow is measured in various ways. It can be expressed as air velocity, air changes per hour, or percent filter coverage. Now, the other method for measuring airflow rates is called percent filter coverage. It is approximate as compared to the others. How do you measure air velocity? It's measured using a thermal anemometer. Okay, here's a new subject, air balancing. I've referred to it a couple of times here. How about temperature? So temperature, room temperature for a typical clean room is normally held at about 70 degrees Fahrenheit. Now, relative humidity. Relative humidity is actually of greater importance than temperature because it can have a direct bearing on the product quality. Now, in some drier areas of the country, like Texas, makeup air may actually require something the other way, and that's humidification to increase the RH of the clean room air. Electrostatic control. So when you have low humidity levels in a pharmaceutical clean room, that can build up static electricity in your equipment. Here's a little bit of physics here. So ions are gas molecules, oxygen, nitrogen, and carbon dioxide. Now, okay, so we've talked about ionization. The basis of environmental control in pharmaceutical clean rooms is air filtration. Now, these filters are sealed to the housing using a gel-like seal, and it's important that that seal does not promote microbial growth and also that it can be easily cleaned. Okay, so for air filtration, very necessary to prolong the life of terminal HEPA filters to have pre-filters. The subject of HEPA integrity testing, another word for this, of course, is leak testing. Now, to perform this leak testing or integrity testing, the air upstream or downstream of the HEPA filter is measured for particulate using what's called a light scattering photometer. In modern pharmaceutical clean room HVAC systems, it's essential to have an automated control and monitoring system. Now, this system performs its control tasks based on a set of alarm control and monitoring points. Now, a quick note about personnel here. Personnel are the biggest source of microbial contamination in the clean room. Humans carry millions of bacteria on their body. These coverall suits can be either disposable or reusable. Now, typically the reusable suits that are available are made with woven polyester blend fabrics. Okay, so another topic here that's important for environmental control is cleaning and sanitization. It's an essential part of environmental control, and typically disinfectants are used to serve to reduce the level of microorganisms on an inanimate object. Now, when you're cleaning the room, that's absolutely necessary prior to sanitization. The reason is any residue that must be removed from a surface in order for that disinfectant following to be effective. Really important that your SOPs for cleaning and sanitization are comprehensive, and you can see a list of items that should be included in those SOPs. Okay, so we talked a lot about HVAC and the different controls. How do you validate your HVAC system? It verifies that the individual components of the HVAC system operate within their specified range and meet the acceptance criteria set by the system designers. There's a pressure differential stress test. Also, you'll want to do a power failure and recovery test. So those are OQ tests. You'll want to go to the PQ or performance qualification, and this verifies that the HVAC system meets all acceptance criteria under dynamic operating conditions. As part of the PQ, you'll also want to do an airborne bioburden test. So that brings us to the end of the webinar.
First off, I'd like to thank everybody for listening. I realize it's a very complex subject with a lot of detail, but I hope each and every one of you has received some little nugget of information that you can use within your own facility to assess the HVAC system. So again, thanks very much for listening.
Once again, thank you, Roger, for the great presentation. And so that does conclude the session for today. Thank you, everyone, for participating. You may all disconnect now. Have a great day ahead. Bye-bye.
Bye now.